Just as you can combine two real numbers using addition, subtraction, multiplication, and division, you can also combine two functions. So let f and g be two functions with intersecting domains. Now, when we say intersecting domains, we're talking about values of x which are common to both the domains of f and g. Then for all x values in the intersection, the sum, product, difference, and quotient of f and g are new functions defined as follows. Now the sum of f and g of x is equal to f of x plus g of x. The difference of f and g of x is equal to f of x subtract g of x. The product of f and g of x is equal to f of x multiplied by g of x. The quotient of f and g of x is equal to f of x divided by g of x, where g of x cannot equal 0. So for each new function, the domain consists of those values of x common to the domains of f and g. Now, if you look over here, we can see the domain of the quotient function is further restricted by excluding any values that make the denominator g of x 0. Example 1. Given f of x is equal to x squared plus 4x, g of x is equal to the square root of x plus 2, and h of x is equal to 3x minus 5, find each function and its domain. Part A. The sum of f and g of x is equal to f of x plus g of x. Now, f of x and g of x can be replaced with what we have here and what we have here to give us the following. Now, when we remove the brackets, we have this simplified new function for the sum of f and g of x. Now, the domain of f is this open interval here, which is all of the real numbers, and the domain of g is this interval here. So it's closed on the left-hand side, so it includes -2, and it's open on the right-hand side as it doesn't reach in positive infinity. Now, it's visually represented on a number line like so. Now we want the domain of this new function, the sum of f and g of x. So what we'll do is find the intersection of these two domains, or where they overlap, to give us the following. So the domain for the sum of f and g of x is equal to what we have here. Part B. The difference of f and h of x is equal to f of x subtract h of x. Now f of x and h of x can be replaced with what we have here and what we have here to give us the following. And when we remove the brackets, we get the following, and when we simplify what we have here, the final new function is what we have here for the difference of f and h of x. Now the domains of f and h are what we have here. So it's the open interval from -infinity to positive infinity for both. So they're both set of real numbers. Now we want the domain of this new function here. So we want the intersection of these two domains, or where both of these two overlap. And you can see it's exactly the same domain. So the domain of the difference of f and g is what we have over here. Part C. The product of f and h of x is equal to f of x multiplied by h of x. F of x and h of x can be replaced with what we have here and what we have here to give us the following. And then we'll expand this bracket using the distributive property to give us the following. And when this is simplified, we get this new function for the product of f and h of x. Now, as the domains of f and h are the same, we saw in the last example that the domain of the product of f and h of x will also be the same. And we write the interval like so. Part D. The quotient of h and f of x is equal to h of x over f of x. Now h of x and f of x can be replaced with what we have over here and what we have over here to give us the final new function for this quotient function here. Now the domain of f and h are both the same. So we'd expect the domain for this new function to be the same as well, where the intersection of these two occur, or where they overlap, like so. However, because this is a quotient function, x equals 0 or x equals -4 yields a 0 in the denominator of this quotient function h and f. So we need to exclude these values of 0 and -4 from here, like so. And we can see then there's 3 sets of intervals, and we want the union of this interval with this interval and this final interval over here, which we'll write like so. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. Now let's begin with the notation for composite functions. So how would we pronounce this? Well, we'd say f of g of x. And we can shorten this even further. So we can say this as f of g. And an equivalent notation for this is what we have here. Now, if you see either of these two notations, then we're dealing with a composite function. So what is a composite function? Well, a composite function is a function that depends on another function. So in this case here, we have the function f, which depends on the function g. Okay? And a composite function is created when one function is substituted into another function. So in this case here, the function g of x is substituted into the function f. So let's try and visualize all of this to understand this better with a diagram. So we begin with the domain of g. So we pick a value of x. We input this into the function g. And then we get a value for g of x. Okay, we can get a range of such values depending on which value of x we've inputted into g. Now these values for g of x are then inputted into the function of f. Because we input these values of g of x into f, this then becomes the domain of f. So then we get the final output of this composite function, so f of g of x. So essentially what happens is the composite function maps values of x in the domain of g to the composite function f of g of x. Example 2. Given f of x is equal to x squared plus 1 and g of x is equal to x minus 4, find each of the following. Part A. The composite function f of g of x can be rewritten as the following, going by the definition of the composite function. Now, g of x can be replaced with x minus 4 because they're equal, and that'll give us the following here. And because x minus 4 is being inputted into the function f, we can replace the x here with x minus 4, and that'll give us the following here. And we can use the distributive property to expand this bracket to give us the following. And then when we simplify what we have here, we get x squared minus 8x plus 17. Part B. So we have this composite function for g of f of x. And we can write its equivalent like so using the definition of the composite function g of f. Now, f of x over here, we can replace with x squared plus 1 because they're equal to each other. Okay, and we get the following. Now, because x squared plus 1 is being inputted into g, we can replace the x over here in the function for g with x squared plus 1 to give us the following. Okay, and then we can simplify this to finally give us x squared minus 3. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following.